You walk into a room. The lights are low. The air is thick with anticipation, and on the table in front of you are 5 envelopes. Each one contains a riddle, but not just any riddle. These are the kind of questions that have stumped scientists, inspired Nobel Prizes, and made even the sharpest minds pause. Only geniuses, they say, can answer these 5 physics riddles. But what if genius isn't about knowing the answer, but about daring to ask the right questions? Tonight, you're not just a spectator. You're a participant in the greatest game of all, understanding the universe. Are you ready to play? Let's start with a warm-up. Imagine you're standing on a perfectly smooth, frictionless ice rink. You're holding a heavy medicine ball. There's no one else around, no wind, no slope, just you, the ball, and the endless gleaming ice. Here's the riddle. If you throw the ball as hard as you can in one direction, what happens to you? Most people's first instinct is to say nothing. I just threw a ball. But physics says otherwise. In fact, the moment you hurl that ball forward, you'll start sliding backward. Why? Because of Newton's third law. For every action, there's an equal and opposite reaction. The ball moves forward, you move back. It's not magic, it's momentum. But here's the twist. If the ball is heavy enough and you throw it fast enough, you could actually move across the entire rink without ever taking a step. That's the power of physics. It turns the ordinary into the extraordinary. But let's not stop there. Let's make it harder. Riddle number 2. Picture a sealed box. Inside there's a cat, a vial of poison, and a radioactive atom. You can't see inside the box. You can't hear anything. The box is perfectly isolated from the outside world. The question is the cat alive or dead? If you've heard of Schrodinger's cat, you know this isn't just a question about felines. It's a question about reality itself. In the strange world of quantum mechanics, until you open the box and look, the cat is both alive and dead at the same time. It exists in a superposition of states. Only when you observe it does reality choose one outcome. This isn't just a thought experiment, it's a window into the weirdness of the quantum world, where particles can be in 2 places at once, and the act of looking changes what you see. Genius isn't just about solving the riddle, it's about realizing that sometimes the answer is stranger than the question. Now let's raise the stakes. Riddle number 3. You're in a spaceship, far from any stars or planets. You're floating in the void, weightless. Suddenly you feel a force pressing you into your seat, but there's no engine firing, no thrusters burning. What's happening? Here's the clue. Einstein once said, "The happiest thought of my life was that a man in free fall feels no gravity." The answer lies in the principle of equivalence. In Einstein's universe, there's no fundamental difference between gravity and acceleration. If you feel pressed into your seat, it could be because you're accelerating or because you're in a gravitational field. In deep space, if you feel a force, it means your ship is accelerating. Gravity and acceleration are 2 sides of the same coin. This insight led Einstein to the theory of general relativity, which describes gravity not as a force, but as the curvature of space-time itself. Genius, in this case, is about seeing connections where others see differences. Let's keep going. Riddle number 4. You're holding a flashlight. You turn it on, and a beam of light shoots out at 299,792,458 meters per second, the speed of light. Now imagine you start running forward at half the speed of light. How fast does the light move away from you? Common sense says it should be the speed of light minus your speed. But physics says no. No matter how fast you run, the light always moves away from you at the same speed, 299,792,458 meters per second. This is one of the strangest, most counterintuitive facts in all of science. It's the foundation of Einstein's special relativity. Time slows down, lengths contract, and mass increases, all to keep the speed of light constant for every observer. The universe bends its own rules to make this happen. Genius isn't just about knowing the answer. It's about being willing to accept that the universe is stranger than you ever imagined. And now the final riddle. Riddle number 5. You're standing at the edge of a black hole. You drop your watch into the abyss. From your perspective, you see the watch slow down, its tick stretching out, until it seems to freeze at the event horizon. But if you could somehow ride along with the watch, you'd see it tick normally as you fell in. How can time move at 2 different rates for 2 different observers? This is the mystery of time dilation, a consequence of both special and general relativity. Near a massive object, time slows down. For someone far away, your watch appears to stop. For you, time feels normal. Both perspectives are correct, even though they seem to contradict each other. Genius is about holding 2 seemingly impossible ideas in your mind at once and realizing they're both true. So how did you do? Did you solve the riddles, or did they solve you? The truth is, physics isn't about having all the answers. It's about asking better questions, It's about being willing to let go of common sense and embrace the weirdness of reality. The greatest minds in history, Newton, Einstein, Schrödinger, didn't just accept the world as it was. They challenged it. They asked what if and why not. And in doing so, they changed everything. But maybe you're thinking, these riddles are fun, but what do they have to do with real life? The answer is everything. The same principles that explain why you slide on ice, or why a cat can be both alive and dead, or why time slows down near a black hole. These are the principles that power your smartphone, guide GPS satellites, and make modern technology possible. Physics isn't just a subject in school. It's the operating system of the universe. And here's the real secret. You don't have to be a genius to understand physics. You just have to be curious. You have to be willing to ask questions, to make mistakes, to be confused, and to keep going anyway. The universe rewards curiosity. Every time you ask why, you're taking a step closer to understanding the deepest secrets of reality. So are you ready for more? Because the next riddle is the biggest one of all. Why does the universe exist at all? Why is there something rather than nothing? That's a question even the greatest geniuses are still trying to answer. Maybe, just maybe, the next genius to crack the code is you. Let's take a breath and look back at what just happened. You've faced 5 riddles that have challenged the very way you see the world. But if you're still here, still curious, you're already thinking like a physicist. Because physics isn't just about equations and numbers, it's about seeing the invisible threads that connect everything, about finding the extraordinary in the ordinary. So let's go deeper. Let's not just answer riddles. Let's unravel the stories behind them, the real-life mysteries, and the moments of insight that changed the course of science forever. Think back to that first riddle, the one with the medicine ball on the ice. It's a simple setup, but it hides a profound truth. When you throw the ball and slide backward, you're experiencing the law of conservation of momentum. This law isn't just a classroom rule. It's a universal principle. It's why rockets can soar into space, even in the vacuum where there's nothing to push against. The rocket throws exhaust backward, and in return it moves forward. The same law explains why galaxies spin, why stars are born, and why you can't move without affecting the world around you. Every action has a reaction, every push has a pull. It's a dance that never ends, from the smallest atom to the largest galaxy. But let's not stop at the ice rink. Let's zoom out, way out, to the edge of the universe. Imagine 2 galaxies, billions of light years apart, drifting through the cosmic void. When they pass close to each other, their mutual gravity pulls them into a spiral, flinging stars and gas in every direction. The conservation of momentum governs this cosmic ballet, just as it governs your sliding on the ice. The same law, the same principle, everywhere and always. That's the beauty of physics. It reveals the unity beneath the diversity, the order beneath the chaos. Now let's revisit Schrödinger's cat. It's easy to laugh at the idea of a cat being both alive and dead, but the real lesson is deeper. Quantum mechanics isn't just weird, it's revolutionary. Before quantum theory, scientists believed the universe was like a giant clock, ticking away according to fixed laws. But quantum mechanics shattered that certainty. Suddenly particles could be in 2 places at once, could tunnel through barriers, could pop in and out of existence. The universe became a place of probabilities, not certainties. This isn't just a philosophical puzzle. Quantum mechanics is the foundation of modern technology. The computer or phone you're using right now relies on quantum effects in its microchips. Lasers, MRI machines, solar panels, all of them exist because we learned to harness the strange rules of the quantum world. And yet the mystery remains. No one fully understands why the quantum world behaves the way it does. Even Einstein, the greatest physicist of the 20th century, struggled with it. God does not play dice with the universe, he famously said. But the universe, it seems, does play dice, and we're still learning the rules of the game. Let's move to the spaceship. Floating in the void. The principle of equivalence, the idea that gravity and acceleration are 2 sides of the same coin, was Einstein's great insight. Before Einstein, gravity was a force that pulled objects together. But Einstein saw something deeper. He realized that gravity isn't a force at all. It's the curvature of space-time. Massive objects like the Earth or the Sun bend the fabric of space and time, and objects move along the curves. That's why planets orbit the Sun, why apples fall from trees, why light bends around stars. It's not because they're being pulled by an invisible force, but because they're following the straightest possible path in a curved universe. This idea was so radical that even Einstein doubted it at first. But in 1919, during a solar eclipse, astronomers observed starlight bending around the sun, just as Einstein predicted. Overnight, Einstein became a global celebrity, and the world saw that the universe was stranger and more beautiful than anyone had imagined. Today, GPS satellites rely on Einstein's equations to keep your phone's map accurate. Without general relativity, your GPS would be off by miles every day. The riddles of physics aren't just brain teasers, they're the keys to understanding and navigating our world. Now, let's return to the flashlight and the speed of light. This riddle isn't just a curiosity, it's the foundation of modern physics. Before Einstein, scientists believed that light, like sound, needed a medium to travel through. They called it the ether. But experiments failed to detect any ether, and the speed of light remained stubbornly constant no matter how fast you moved. Einstein's genius was to accept this fact, even though it defied common sense. He realized that if the speed of light is always the same, then time and space themselves must be flexible. Time can slow down, distances can shrink, and mass can increase, all to keep the speed of light constant. This isn't just theory. It's been tested again and again, in particle accelerators and atomic clocks, in the GPS satellites orbiting above your head. Every experiment confirms Einstein's insight. The universe is built to keep the speed of light constant no matter what. It's a rule so fundamental that it shapes the very structure of reality. And finally, the black hole and the mystery of time. Time dilation isn't just a mathematical trick, it's a real, measurable effect. Astronauts on the International Space Station age a tiny bit slower than people on Earth because they're moving fast and are farther from the planet's gravity. Near a black hole, the effect becomes extreme. Time slows to a crawl, and at the event horizon it seems to stop altogether. For the falling watch, time ticks normally. For the distant observer, it freezes. Both are right, even though their experiences are completely different. Physics is full of these paradoxes, these moments when reality seems to split in two. But instead of being frustrated, physicists see these moments as opportunities. Every paradox is a clue, a sign that there's something deeper waiting to be discovered. The universe is a puzzle, and every riddle is a piece of the solution. Let's step back and ask, why do these riddles matter? Why do physicists spend their lives chasing questions that seem impossible, or wrestling with paradoxes that make your head spin? The answer is simple but profound. Every time we solve a riddle, we peel back another layer of reality. We get closer to the heart of how the universe works. And sometimes the journey is just as important as the destination. Think about the first time you learned to ride a bike. At first it seemed impossible. How could you balance on two thin wheels? But with practice, you learn to trust the physics, to feel the subtle shifts in momentum and balance. Physics riddles are like that. They force you to let go of your assumptions, to trust the logic of the universe, even when it feels counterintuitive. The more you practice, the more you see the hidden patterns that connect everything. Let's revisit the ice rink, but this time imagine you're not alone. You and a friend are both standing on the ice, each holding a medicine ball. You both throw your balls in opposite directions at the same time. What happens? You both slide away from each other, propelled by the force of your throws. But here's the twist. If you measure your speeds, you'll find that the total momentum before and after the throw is exactly the same. Nothing is lost, nothing is created. The universe keeps perfect track of every push and pull. This is the law of conservation of momentum in action, and it's one of the most powerful tools in all of science. Now, let's take that idea and scale it up. In the heart of a star, nuclear fusion is happening every second. Protons slam together, fusing into heavier elements and releasing energy. But the total momentum, the total energy, the total charge, these are all conserved. The same laws that govern your sliding on the ice also govern the birth of stars and the creation of the elements that make up your body. You are quite literally made of stardust, shaped by the same physics that rules the cosmos. Let's return to Schrodinger's cat, but this time, let's open the box. In the real world, when you look inside, you see either a living cat or a dead one. The act of observation collapses the quantum superposition into a single outcome. But what does that really mean? Some physicists believe that every possible outcome actually happens in parallel universes. In one universe, the cat lives, in another it dies. This is the many worlds interpretation of quantum mechanics, and it's as mind-bending as it sounds. If it's true, then every choice you make, every riddle you solve, creates a branching universe. Somewhere out there, another version of you is living a different life, solving different riddles. But even if you don't buy the many worlds idea, the lesson is clear. The universe is far stranger than we ever imagined. The rules of the quantum world are not the rules of everyday life. But by studying them, we've unlocked technologies that have changed the world. The next time you use a computer, remember, you're harnessing the power of quantum riddles. Let's revisit the spaceship, but now imagine you're falling toward a planet. You feel weightless even though gravity is pulling you down. Why? Because you and your spaceship are both accelerating at the same rate. There's no force pushing you into your seat, no sensation of weight. This is the principle of equivalence in action. And it's why astronauts in orbit feel weightless, even though they're still under the influence of Earth's gravity. They're in free fall, moving along the curved paths dictated by space-time. This idea has practical consequences. When engineers design satellites, they have to account for the curvature of space-time. If they didn't, our communications, our weather forecasts, our navigation systems would all fail. The riddles of physics aren't just abstract puzzles. They're the foundation of modern life. Now let's return to the speed of light. Imagine you're in a car, driving toward a traffic light. If you speed up, the light seems to approach faster. But with light itself, no matter how fast you move, the light always comes at you at the same speed. This is so strange that it took decades for scientists to accept it. But once they did, it opened the door to a new understanding of time and space. Time can stretch, space can shrink, and the universe itself can expand. The speed of light is the ultimate speed limit, the cosmic speedometer that keeps everything in check. And finally, let's revisit the black hole. Imagine you're falling in, watching the universe above you. As you approach the event horizon, the outside world seems to speed up. Stars race across the sky, the universe ages in a flash. For you, time feels normal, but for the rest of the universe, you're frozen in place. This isn't just science fiction, it's a real prediction of Einstein's equations, confirmed by observations of black holes and neutron stars. So what's the lesson of these riddles? It's not just that the universe is strange, it's that the universe rewards curiosity. Every time you ask a question, every time you challenge your assumptions, you get a little closer to the truth. The greatest discoveries in history started with a simple question: what if, or why not? The next time you face a riddle, don't be afraid to get it wrong. Don't be afraid to be confused. That's where the magic happens. Physics isn't just for geniuses. It's for anyone who's willing to ask questions, to make mistakes, and to keep searching for answers. The universe is a puzzle, and every riddle you solve brings you one step closer to understanding the whole.